Hi everyone, let's revise resistance. So basically what is resistance? Well, resistance is something that opposes the flow of current. And when you have the larger resistance, it is harder for current to flow. So say for example, you have a circuit and then you have a resistor here. So when the current flows through the resistor makes it harder for the current to pass through. So there is a resistance that makes current flow slower. So of course, if this is a 2 ohm resistor, it will slow down the flow of current. If it is a bigger one, let's say 12 ohms, it will slow down the current even more. So the higher your resistance of your component, the smaller the current. Because remember, current is basically telling us what is the rate of flow of charges. Okay, current is the rate of flow of electric charges. So rate means how fast the charges are flowing. So if your resistance is very high, your electric charges cannot flow fast. So your current would then be smaller. The symbol is R for current. Remember, this is not the unit. Okay, the symbol. Symbol means instead of writing out the entire word resistance, I can actually replace it just with this letter R. But when I measure current, the unit is in ohms. Okay, OHM, and the unit is written like that, ohms. All electrical components have resistance. It's just whether it has high or low resistance. So what are resistors? Well, in an electrical circuit, we will put resistors in the circuit to control the amount of current flowing in different parts of the circuit. Basically, there are two kinds of resistor. We have the fixed resistor and also variable resistor. So a fixed resistor will be a resistor that is fixed in its amount. So if it's a 5 ohms resistor, it will remain 5 ohms. Actually, you see these strips of colors here. Different resistors um, will have different kind of color combination. So there's a convention, we look at the colors, we will know what is the resistance of that resistor. And this is the symbol. Be very careful, do not draw it this way, because this actually means a fuse. So a lot of students confuse. This is resistor. All right, so they are different. We also have variable resistor. Variable resistor means I can actually control. So in this case, I can glide this glider here. I can glide it to the left or right, and then I can change the resistance. This one I can actually rotate it, turn it, and then I will change the resistance as well. So sometimes it is used as a dimmer in our electrical circuit. So if we want the light to become dimmer or brighter, this is what we can do to adjust the resistors. And when we adjust the resistance, we also change the amount of current. So this is the symbol. Take note of the direction that this arrow is pointing. And resistors, like all other electrical components, they can be connected either in series or in parallel. So take note that when the resistors are in series, they actually have a combined resistor. So this is a 10 ohm, this is 10 ohm. So when you put them together, there is a combined resistance, and we call it the effective. We don't call it combined resistance. There's a term for it. We call it effective resistance. So when two resistors are side by side in series, then the effective resistance becomes larger. So you see, each one is 10 ohms, right? 10 ohms, 10 ohms. When I combine them together, the effective resistance will be larger. Now, what happens when we put them in parallel? The same thing, we have two 10 ohm and 10 ohm resistor, and so individually they are 10 ohms and 10 ohms. But when I put them in parallel, then the combined resistance or the effective resistance has a value that is smaller than individual one of them. Okay, and in fact, you do not need to know the calculation, but if let's say I have a 2 ohm resistor here and I have a 10 ohm resistor here, right? This is 2, this is 10. And when I connect them in this way, the effective resistance, which I'm going to use the symbol R with the subscript E, the effective resistance will be smaller than the smaller one here, smaller than 2 ohms. So the more I put them in parallel, the smaller the effective resistance will be. So if I have one resistor, two resistors in parallel, so let's say this is 3 ohms, 3 ohms. So the effective resistance is small. If I were to connect one more, it will be even smaller. So the more I connect in parallel, and I connect one more, the effective resistance will be even smaller. So take note, when you combine resistors in parallel, you are actually making the effective resistance smaller. All right, so you're actually making the effective resistance smaller. But when you connect them in series, okay, when you connect them in series, then your effective resistance actually become bigger. So this is what you need to know. Pardon me for my handwriting. Okay, so that's all you need to know for resistors. Oh yes, one more. How do you measure resistance? Well, you can actually use a multimeter, and that can allow you to find the resistance of the resistor.